सब लोग आगे भाई ठीक है Good afternoon, and I welcome you all in this lady session after the lunch. And I will try my best to wake you all up. But you also you can say cooperate with me and just try to be awake. So yesterday we are talking about the laboratory investigation. So today we will talk about the field investigation. Because when we are working in the laboratory, we are taking the sample from the field. Okay, either it's undisturbed sample or the disturbed sample. So how we take the sample from the field, and sometimes we encounter such kind of this data in which you cannot take any kind of the sample. So in such a condition, we conduct certain tests in the field. Those are called as the field tests. So today we are discussing about all these tests. So basically, what are the river engineering projects? It could be dams, barrages, canals, river training works. I think all of you are familiar with the river training works. It could be embankment or levees, guide banks, grants, artificial cutoffs, pitch ice islands. So these are the basically the you can say river engineering work. So there are some pictures. Homogeneous dams. If you talk about the dams, it could be homogeneous dams or it could be John Dam. On the left side, there is a canal in here. That is an unlined canal. And this is a picture of the lined canal. I think everybody is familiar with that. This is the picture of the barrage. This is your weir. What is the difference between weir and barrage?
First level. Here is cut off without gate. Without gate, sir. Where is it without gate?
In case of the weir, we are allowed to pass the water from the top, but in case of the barrage, we don't allow. To control the we can say flow of the water, we use the gates. So this is a picture of a typical dam, Tehri Dam. In the previous lecture, sir has discussed in length about the Tehri Dam. So basically, what is the dam? Dam is a structure that is built across a river to store the water, and that will use for the different purpose. Either it's irrigation, water supply, power supply, and so on. So, if you talk about regarding the classification of the dams, in broad way, according to the construction material, when we can classify the dams in the following categories: earthen dams, rock-filled dams, masonry dams, concrete dams, steel dams, arch dams, and timber dams. If you talk about the India, this is regarding about the India. The highest earthen dam is the Bansura Sagar Dam, that is in Kerala. And we talk about the Rockfield Dam. It is a Tehri Dam, it is in Bhagirathi River in Uttarakhand. And if we talk about the Masonry Dam, it is Nagarjuna Sagar Dam in Telangana. Concrete dam is the Bhakra Dam on Satluj River. If you talk steel dam, there is no steel dam in India. Arch dam, it is in Idukki Dam, that is in Kerala. Timber dam, it is a temporary structure. Most of the in northern states, you will find such kind of structures. Sir, in the previous lecture, sir has already explained to you, depending upon the storage capacity, International Commission on Large Dams, we can classify the dams in three categories. Small dams, less than 5 meter, medium dams, 5 meter to 15 meter, and large dams, more than 15 meter. But there is one more definition. If the capacity of the reservoir is more than 3000 cubic meter, and the height is between 10 to 15 meter, that also comes under the large dam. So these are the broad classifications. If you talk about the India, these are some certain data is there. The highest dam, Tehri, Bhakra, Idukki, Kol Dam, Sardar Sarovar. So we have sir, this was already you have seen that in the previous lecture. So let's talk about the embankment dam. So what is the embankment dam? We have in the previous lecture we have discussed in length. What is the embankment dam? Embankment dam is a fill dam that is constructed earth and rock fill material. It is called as embankment dam. So depending upon the material, there are the two kind of the embankment dam. One is the homogeneous dam. Second is John dam. Homogeneous means uniform construction materials. The dam in which single type of the construction material is used called as homogeneous. Second is John dam. John means different portions. So this is the dam in which clay core is centrally provided, impervious core is centrally provided, and on the both side, upstream and downstream, some shell material, casing material are provided. It is called as the John dam. So these are the typical picture. This is the homogeneous dam. This is a John dam, and at the center you can see there is a clay core or a impervious core is there. The core could be clay core, asphalt core, or any other material that is impervious to water. This is Rockfield Dam. At centrally, there is a clay core is there, and on the both sides, rockfill material is there. So here, what we are discussing, sir was discussing about the ferritic line. The ferritic line is also shown in this picture. From here, you can see that the chimney filter is provided when the ferritic line pass. Whatever the water is seeping through the dam, that is taken by the chimney filter and drain off towards the toy drain. So let's talk about what are the requirements. Suppose you have a project of embankment dam and you are going to construct it. So what are the requirements that you require? In case of the casing or cell, what is the material requirement? It should be pervious. What is the advantage if of being pervious? Anybody? Sir has discussed the casing of the shell of the John dam should be pervious, because if it is not pervious, there are chances of development of the pore pressure. Okay, so in case of the casing, we choose such kind of material. This is pervious. It means it has the high permeability, so there is no chance of development of the pore pressure. Second thing, the second function of the casing is to provide the support to the core. Third is protection to the core. And if we talk about the core, so these are the requirement of the core. It provides the water tightness. Why are building a dam? To store the water. If our core is not impervious, what will happen? All the water will pass through it. So main function, our casing is pervious. Then how we store the water? So our core should be impervious. Second thing is low compressibility. It means the settlement of the core after the construction should be less. Otherwise, what will happen? Somebody was asking in the bank, sir, hum freeboard come. How is the overtopping take place? Okay, so there are chances if it is high compressible, there is a high, you can say settlement is high, and your freeboard is not sufficient to take the water. Okay. Third is that it should have a good shear strength. If it has a good shear strength, both the upstream slope and the downstream slope both are stable. So when we are choosing the material, we choose the material that fulfill all these our requirements. So for a dam or any river valley project, we carried out the two kind of the investigation. One is the bore area investigation. Second is foundation investigation. Bore area means the area we take the samples. We take the material that are called the bore area. Okay. In case of the earthen dam, what we take from the, you can say, bore area, we collect the soils. So the economy of any project depends upon the location of the bore area. Suppose your bore area is quite far from your site location, then you have to take it, the lead will be quite high, and it will, you can say, increase the cost of the construction of the dams. And the foundation investigation, why it is important? The foundation investigation is important so that your project is stable. It should not have the excessive settlement. It should be sound, and whatever the load that is coming on the foundation, it should be safely transferred to the lower strata. So these are the requirements for the bore area and foundation investigations. These are the purpose of the bore area investigation. First thing, suppose when you are planning to for the construction of a dam or any project, your embankment, levees, grants, spurs. So you try to find out where is the material is available. So first thing is you find out what is the if the material is available locally. If material is available, how much quantity is available? Okay, what are the properties of this material? Whether I can use this material in my project or not, and how far it's from my site. So all are the deciding factor when you are choosing the bore area. So once you have identified your bore area, you will collect the sample from the bore area. Okay. So normally in case of the bore area, since you are taking a sample and constructing your embankment, yeah, whatever the structure you have, so we collect the disturbed samples. We collect the sample in bags on, but how we collect? So this is the picture how we collect the soil samples. In one picture, you can see it here. Normally, what we do, we identify the bore area and we make the pit 3 meter by 3 meter by 3 meter. Okay, and we collect the sample depending upon your material requirement. If your material is available more than 3 meter, yeah, you can say you don't have the quiet, then we can go much deeper. And for the collection of sample, from where you will collect the sample? Any idea? So here they are collecting the samples. It's not working. So should I collect the sample from here? Where I have to collect the sample? Point is that when you are using the material, you are using from this to this thickness. Okay. So whatever the sample you are collecting, that have the properties of this layer. Okay. So you will collect the sample by scratching from the top to the bottom, and you will take that sample to the laboratory. In CSMRS, what we do, we leave the top 30 centimeter layer, because what is happening at the top layer, these are the normal fields. There the vegetations are there, and up to 30 centimeter, the roots are there, okay, which is the organic matter, okay. So that will create the problem in your embankment. So leave 30 centimeter and collect the sample from top to bottom. Here there is one more picture is there. When you are collecting the sample, after certain depth, you find that there is another kind of material. You can visually see it. Okay. Under this situation, what will you do? You will collect the sample from the body layer and measure the thickness and test in the laboratory, depending upon the competency and suitability of the material. When you are working out how much material is available, so in that way it will help. If you have the, you can say, the thickness of the layer and you have the area, you can calculate okay, that much material is available in my that the bore area. So these are the logs. In the left side you can see this is left. How we show it? We have collected the sample from this left to this point. Okay? And here we have written that 0.3 to 1.5 meter, 0.3 to 1.4 meter with your water tank. After that there was another kind of the soil is there, and that was don't appears to be suitable. So we have collected only up to 1 meter. So while when you are collecting the sample, you have to take care about this one. So these are the pictures. When collecting the samples by making the pit of 3 meter by 3 meter, you are measuring the depth here. So you can collect the sample either by the engaging the labor or the machines also. But if you engage the labors, what will happen? To make the 3 meter by 3 meter by 3 meter pit, it will take many days. By the machine, you can simply you can say few hours you can do that job. So now the question arises, you have identified a more area. Suppose this is your bore area. How you collect the sample? The sample should be collected in such a way that the overall sample should be representative of your whole bore area. Okay? It should not be like that. If you are collecting only sample from the center and you are saying, sir, please return to my whole area. Sample should be evenly spread in whole area. So this is the one of the picture. In this picture, we have divided the whole area into grid patterns. The grid is there, and from the center of the each grid, we have collected the samples. So when you talk, so it means samples are uniformly distributed, and whatever the results are coming, they will represent the complete area. Either it could be a square pattern. So this is the real picture. This is about a dam picture where the bore area is the, you can say, reservoir area. So samples were collected along the dam axis, and then the yellow, you can say, marking is on the location of the sample from they are collected. So now you are collecting sample. So now the question arises, how much sample you require to collect? Suppose you have identified a bore area, and that bore area you have estimated that okay, my 1 lakh cubic meter, 10 lakh cubic meter material is available. How much sample you will collect? For that IS code 14690 will help us to solve this problem. According to the, you can say, if you are collecting the metal for the core, so according to IS code, it will say for every 2000 cubic meter, you have to run one grain size analysis. For every 15,000 cubic meter, you have to run one permeability and one consolidate and one shear strength test. And for every 30,000 cubic meter, you have to run one consolidation test. So once you have estimated how much bore area is my material is available in that area, so depending upon that material, you will decide okay, how many number of the sample you will collect from that area. Second is shell material. What the code says, for every 1000 cubic meter, you have to run relative density or the density test. What is the relative density? Please ask. कल ही हम लोगों ने बात किया था कि भाई हमारा डायलॉग होगा, इट्स नॉट मोनोलॉग. ओके, इफ आई एम शोइंग यू समथिंग व्हिच यू डोंट नो, तो थोड़ा पूछिए आप लोग, थोड़ा सा अच्छा रहेगा, इंटरेक्शन रहेगा, आप लोग भी जगह रहेंगे, क्योंकि आई नो दिस इज अ लेडी सेशन. प्लीज आस्क, व्हाट इज द रिलेटिव डेंसिटी? In case of the quasi soil, let me tell you, we have determined the MDD, maximum dry density, and OMC. But in case of the sandy soil, there is no MDD or OMC. In that case, there is a relative density. Okay, so density is depending upon that. We determine whether this our can say strata is compact or loose. So if my relative density is more than 85%, it is very good compaction. Up to 35 to 65, it's very good. But if it is less than 35, it is very loose strata. But if you go to the river bed, in case of the river bed, by seeing the soil, okay, you can by conducting test, and you can say okay, this is my loose strata and so on. The relative density is also determined in the laboratory. There is a particular machine is there in which you provide the vibration to the sands. Because this is sands, it is a non-corrosive soil. So by the vibration, it get compacted. So you determine the what is the maximum relative density of that material. Okay. For one 10,000 meter, you have to run one grain size analysis. Next is the filter material. For every 5,000 cubic meter, one gradation and one relative density. So these are our criteria. How you choose the number of the sample? How you determine how much number of sample I have to collect from my a particular bore area? So you have collected the sample from the bore area. So these are the things you have to record in your register, because later on they will going to be helpful. As sir told in the previous lecture, our water resource project take times. It may take 5 year, 10 year, 15 year. So normally bore area investigation is carried out at the DPR stage, and when your actual project starts, it could be after 5 year or 10 year. So most of the time, you will who the person who has carried out the bore area investigation, that is transferred from the sites, and if you don't have the proper location, nobody is going to tell you. You have the reports, but you cannot identify that area. So for that one, first thing, mark the core area on the map. If map is not available, do the survey and prepare the map. Okay. In each map, mark the location of the trial pits from which you have collected the samples. Why it is required? Marking the sample. Suppose in a boro area you have collected the 12 samples. Okay. And when you are tested in the laboratory, you find, okay, my 8 samples are good, I can use this material, but 4 samples are not good. If you don't have the location, how will you identify, okay, my this material is. So to mark that area, to do, yeah, delineate that area, you require the location of those samples. Okay, so this is my good area, this is my bad area, so I have to leave it this one. So that's why you have to take either take the coordinates, whatever the thing you want. Nowadays there is a lot of, we can say, methods are there. Second is measure the number of this, also record the how many sample have you collected, distance to the sample. I'll also record the depth of the sample, because it will help you to calculate how much, can say, material is available in that area. And when you sending the sample to the laboratory, mark the sample very clearly, number, identification number, because whatever you information you are providing to the laboratory, the report will come with those identification. So mark it very clearly. So once you have tested in the laboratory, yesterday I have shown you, depending upon your material, you can say, okay, you can classify the material very suitable, suitable, fairly suitable, poor, and non-suitable. Yesterday we have discussed the most suitable material for the core is clay. What is it? GC. What? GC. Clay. And the suitable is Cl and Ci. Clay of low compressibility and clay of medium compressibility. Why I am saying, why the IS code telling you you should use GC material, because this is the most suitable. Why? Have you thoughts about that? एक क्ले ग्रेवल, एक क्ले मटेरियल जिसके अंदर ग्रेवल है आपका, मतलब जो पार्टिकल साइज है 4.75 टू 80 mm. इट वाज सेइंग लाइक दैट. अगर आप ClCl की बात करें तो उसमें हो सकता है कि आपका 90% 4.75 से नीचे का मटेरियल होगा आपका. That's why, because you know the density, higher the density, if you are using the coarse kind of the material in the clay, so what will happen? It have the more density, more stability, more shear strength. So that's why I scored they say the most suitable material is GC. If GC is not available, then use Cl and Ci. If that is also not available, then use SP, SM and CH. But in case of the SM, when you are using the SM kind of the material, since it is erodible material, then you have to properly design the filter. That take care should be taken in your design. So this is the foundation investigation. So what are the information foundation investigation provide us? Tell me anything. Suppose you are builder, you can say, I think everybody has worked on the project. Okay, आप लोग फाउंडेशन इन्वेस्टिगेशन करते हैं आप लोग? उसमें क्या देखते हैं आप लोग? हार्ड रॉक तक जाते हैं. अच्छा, उसके बाद सपोज करो हार्ड रॉक आपका 100 मीटर पे है, क्या करेंगे आप? हाँ, तो बेसिकली फाउंडेशन इन्वेस्टिगेशन का मतलब है व्हाट एवर योर साइट इज देयर, व्हाट आर द डिफरेंट लेयर्स, वेदर दे आर soils, rocks, weathered rocks, what is their location, what are their properties. Okay, It could be there is some faulty zones are there, shear zones could be there. So your foundation should investigation should be sufficient enough to you can say identify all these things. Okay, what is the water table? So in that way you have to carry it. And what is the depth of the bedrock? So this is the picture of the foundation investigation. You know, it is planned. These are the your boreholes, your drill holes. These are the drill holes, and depending upon the you can say by investigation through the drill holes, we have made a picture, you can say draw the maps in which we this is showing you what are the thickness of the different layers, and you collect the sample and test in the laboratory. You identify what are the properties of these layers.
सर
Yeah.
सर वहाँ एक तो सर decomposed rock लिखा हुआ है सर वो क्या होता है
Decomposed rocks. Rocks contains the chemicals, certain chemicals. So due to this, allow with a period of time they start decomposing. Okay, that is called. Because there are the two methods. One is the weathering, or the decomposition. Weathering of the rocks takes place due to the physical factor, temperature, water, air. But decomposition means some harmful chemicals are there either in the water or other things. Because water table is there, that is called decomposition. So, how we carry out the foundation investigation? Depending upon your structure, yeah, your project. Suppose it is a canal project, then you don't require to go up to the bedrock. You have to, you can say, carry out the foundation investigation up to 4 to 5 meters. That is more than sufficient. So, depending upon the foundation investigation, you decide which kind of the investigation you carried out. There are three kind of the investigation. One is the open pit excavation, second is boring, third is the subsurface sounding. Okay. So this is a picture of the you can say open pit excavation. This was carried out for a interlinking canal project. The canal was around 60 km length. Okay. So for that, so what will you do? Except on the you can say where it's crossing the bridges or other structures. In normal ways, you have to carry out the investigation up to 4 to 5 meters. That is more than sufficient. So we make the pits and collect the sample from the pit. The samples are collected on the undisturbed. In case of the foundation investigation, we collect the undisturbed sample because we have to test it for the shear strength and the compressible characteristics. So we require the undisturbed samples. In case of the bore area, they are the disturbed sample. It is a difference. I told you yesterday. And the second test we carried out about the permeability. We also determined what is the permeability of that strata. So this is the picture, one of the picture. We have collected the sample from the, you can say by making the pit. But here the depth of the pit, you know that it is around more than 15 meter. Okay. So what we have done in that case? So there is a, you can say this machine, you can say JCB kind of machine. It has a large packet. Okay. Malab, 3 and 4% can stand it. They are standing in there and then go at the top of the bottom of the pit and they collect the sample in that. Because what is happening? Earlier we planned that we collect the sample by doing the drilling. But the point was that drilling machine was not working properly, and due to the urgency of the project, we cannot wait that you do float the tender and do bring the another agency. So in that way, we have collected the sample here. So this, what is the boring? Boring means drilling a hole into the ground. That is called boring. Drill holes, bore holes. I think everybody heard that. A drill hole, bore holes. After drilling the bore holes, what do? You collect the sample. You carry out some tests in the bore holes. You carried out the you can say in situ permeability test. So these are the different methods which are used for the drilling. Auger method, shell method, percussion method, wash boring method, rotary method. Now the question is which method you should use. Okay, depending upon the starter, you will choose the drilling method, one of the drilling method. Where we use the auger method, yeah, suitability of the various boring method. IS code 1892 prescribe that in case of the cohesive soil or soft soil, we use the auger boring. And in case of the, you can say, soft to stiff or sandy strata or gravelly strata, we use shell and auger boring. In case of the boulders and rocks, we use percussion boring. And in case of the sandy strata, Yakosi, wash boring. But you can say one rotary boring is there. It is used in all kind of the strata. So, so what is the auger boring? So this is the picture of the auger boring. You know, auger could be this type, spiral type. This could be this type. This could be bucket type. There are three lot of kind of the augers are there. You can use it, and there are the two methods by the auger boring. One is the hand driven by the hand boring. Second is the machine boring. In case of the hand boring, what is happening? You are rotating the auger by hand. Yeah, you are, you can say, punching the ground by the hand. Okay, so the depth of the exploration will be very low. It could be 5 to 6 meter. But when you are using the say machine auger, the depth of the penetration. Yeah, this is the picture of the different kind of augers. These are the augers. So this is the picture of the machine driven auger. By using the machine driven augers, we can explore up to 25 meter. But the drawback of this method is that we are unable to collect the undisturbed soil samples. Whatever the sample we are collecting the disturbed sample. But for the foundation investigation, we require the undisturbed sample. So most of the time we reject this kind of the boring. So this is a typical picture how we carry out the auger boring. Second is the auger and shell boring. If your strata contains some gravelly materials, so what will happen? And if you are using the auger, then auger will not work alone. So in that case, we are using the shell. This is one kind of the drill rod is there, and at the bottom of that rod, a chisel bit is there. If some hard stone is there, so by lifting and dropping it, we are breaking that stone, and whatever the material is pulverized by the, we are taking out by the bailout method. Third is the wash bearing. It is suitable for the only for the sandy soil or coarse soil. In this method, what we do? So this is the typical picture. There is a casing pipe is there. In the casing pipe, there is hollow rod is there. Okay, we supply the water and the pressure. Whatever the material is there, that is coming out from the holes. So in that way we drive. But the here is the thing is that we do not collect any kind of the sample, not disturbed sample, not undisturbed sample. Only we are making the hole. Okay, so this method is also not good. Percussion method. In this method, this method is used for the hard rock and soils. So here, in this case, there is heavy, can say, chisel bit is there, and at the bottom of this, there is cutting is there, and it passes through a tool. We lift it, drop it, lift it, drop it. In that way, but we pulverize the bottom of the stone and boulder is there. So this method is used for the rocky or boulder strata. But this is the very important method. We always recommend for this method. Rotary boring. So this rotary boring is suitable for every kind of strata, whether it's cohesive, non-cohesive, sandy strata, rocky or bouldery. So this is the typical picture of the, you can say, rotary boring. So this is the machine. This is the one of the old water machine. What we do here, the chunk is here. This chunk is rotating with the hand of the water, and the drill rod is passing through that. At the end of that drill rod, some, you can say, some drill bit are attached. That could be you can say diamond core and so on, and that make the hole into the grounds. And whatever the material is there, the water is passing through it, and that material is pass out. So these are the casing and the drill rods. So by this method, we use the different size. We make the different size of the boreholes. Depending upon the size of the boreholes, it could be NX size, 76 mm dia, it could be HX 100, it could be JW 200 millimeters. And these are the drill loads. These are the size are 33, 43. It's again depending upon the depth of your investigation. If you are going for the more depth, then you are using the bigger size of the drill loads. And if your depth of investigation is low, then lower size drill load will be used. But again, is there are some tests are there which prescribe the use of a particular kind of the drill load, like your SPT test. Everybody heard that about the SPT test? SPT test says that we have to use the A kind of the drill load. It means the die of the drill load should be 41 millimeter. But we have seen in the sites the people are using either BX or EX kind of the drill loads. So what will happen? That will give you the wrong SPT values. And on the basis of the wrong SPT values, you are determining the shear strength and you are supplying that data that to the designer, and either your project is over designed or under designed. That will happen. So now you know the various drilling method. Now the question is how much depth you have to make the borehole. How much depth you have to do the investigation. So these are some guidelines are there. So in case of this spread footing, a normal footing, what we do, we investigate twice the width of that building or structures. In case of the deep foundation, twice the height of the dam. But nowadays, IS code 6955 has cleared about that. Okay, what should be your depth of the bearing and how many number of the borehole you have to take. According to IS 6955, if your project in preliminary stage, okay, and the dam height is up to 30 meter, then the depth of the borehole should be one third to half of the hydraulic head. If the rocks are available up to one third to half of the hydraulic head. But if your dam height is more than 30 meter, then 1 and 2 boreholes should be go to the hard rock. This is regarding the preliminary investigation stage. But if you are in a DPR stage, now the investigation guidelines are changed here. Up to 30 meter, one third of the borehole should be drilled up to the depth of your hydraulic head. And above 30 meter to 100 meter, half of these boreholes should be drilled up to the hydraulic head, and remaining half borehole should be go to the, you can say, hard rock, your empirical strata. And what will happen if your dam height is more than 100 meter? And it further describes that two additional rows of the boreholes. There is a, you can see, normally you carry out the investigation along the dam axis, but here what it says, if your dam height is more than 30 meter, you should do the investigation under the two rows, one on the upstream, other on the downstream. But if your dam height is more than 100 meter, so there are three additional lines for the investigation. And the depth of the is equal to the hydraulic head, and 3 or 4 drifts on either bank should be provided. What do you mean drifts? Good. चलिए जानते हैं आप लोग. ठीक है. So these are, you can say, these are our Bibles. Because when normally we don't have any, you can say, guidelines, so we are following the foreign guidelines. But here now IS code is available. So according to the IS code, we have to carry out our investigation programs. And according to this investigation program, that spacing between the borehole should not be more than 30 meter. So this is the picture. This is the drifts. This is the, skipping this one. Okay. So these are the tests we carried out when we are collecting the stem soil sample. We are in the field. We are conducting. These are the tests: in situ density and moisture content. In the field, we are determining in situ permeability. Achha, what will happen? Suppose I'm telling what I'm telling you. Okay, we collect the disturbed sample and we test in the laboratory. But if you encounter a strata is like that, you are unable to collect the disturbed sample. Then what will you do?
pumping out and pumping in test.
No, that is a normal method. Okay, that is a normal method in the field when you determine the permeability, either pumping in method or the pumping out method. In such a case, when you are unable to collect any sample, that case there some field tests are there. You will conduct all those tests in the field to determine what are the characteristics of your foundation strata. So first is the in-situ density. Density is very important for every, whether it's bore area material or the foundation material. First thing the designer will ask कि भाई density क्या है आपकी, जो material है what are the strata density क्या है उसकी. So you have to determine in the field. Okay, how you determine? So these are the methods: plate load test, cross hole test, nuclear density, pocket perimeter. These are the all tests you can run in the fields. Now this is the suitability. This is my slide. This will tell you the suitability of the various tests in the fields. एसपीटी टेस्ट कहाँ कर सकते हैं, किस तरह का स्टाटा होना चाहिए? या एसपीटी टेस्ट इज वेरी सुटेबल फॉर सैंडी एंड क्ले स्टाटा, but if there are some gravels and the boulders are there, you cannot conduct the SPT test. Why? Because when you conduct the SPT test, some boulder and rock is encountered by your sampler, it will not drive. You cannot drive further, and it will give the what? Rebound. Okay. And what that this tells us, this gives the qualitative assessment of the compactness of the strata. SCPT, this is also suitable for the sandy, silty or clay strata, but if there is a gravel and boulders are there, you cannot conduct this test. This test gives us about regarding the density and strength of the clays and sandy soils and continuous evaluation of the underlying shear strength of the clays. Dynamic cone penetration test, again it is suitable for the sandy, silt and clay soils, not suitable for if the strata contains the gravel and boulders. I will come to the later how I will conduct, how the machine looks. Simple now see where they are applicable or not. Okay, it gives the same as because dynamic cone penetration test and static cone penetration test, they are both the same. There is a little differences there. I will tell you later what is that. Plate load test. Plate load test is suitable for sandy, gravelly or baldy strata. It is not suitable for the clay strata or the fat clay. What it gives? अरे प्लेट लोड ये पढ़ा भी होगा भाई आप लोगों ने सबने, क्या देता है प्लेट लोड टेस्ट हमको? हाँ, या इट गिव्स द bearing capacity, settlement, deformation modulus, it all gives about that. But the only limitation of this test, the result are valid up to please
5 meters.
Twice the width of that plate.
5 meters.
Okay, not 5 meter. If you are using the 1 meter plate, 1 by 1 meter plate, then the result are valid up to 2 meter depth. Third is the field vein shear test. It is very suitable for the clay soil. It is not suitable for sandy and gravelly strata. And the last one is the pressure meter test. Pressure meter test we conduct where we are unable to conduct any kind of the other test. Suppose you have a sand with the gravels. You cannot conduct SPT test. You cannot conduct dynamic cone penetration test. You cannot conduct static cone penetration test. Okay, and your depth is around 10 meter. Up to that depth you cannot conduct PLT test. Then what will you do? You have to characterize. You have to provide some data, some strength to the designer. Then what will you do? In that case, this will rescue us. Pressure meter test. Okay. So this gives about the deformation modulus and compressible characteristics of the strata. So how we determine the in-situ density and moisture content? In-situ density, in case of the cossy soil, we determine the moisture content or in-situ density by the core cutter method or by the cell by tubes. So this is a core cutter is normal. Can everybody have seen that? What we do? We drive into the soil into core cutter into the ground. We measure how much the weight is coming and we determine the moisture content. Knowing the bulk density and the moisture content, we can determine the density of that material. So these are the picture how we take the samples in core cutters. Second is the shell by tubes. In case of the boring, when you are making the boreholes and you want to collect the disturbed sample, when you are collecting the undisturbed sample, in that way you can also determine the density of the samples. So what do you in the for the collection of the samples we use the cell by tubes. So this is the picture of the cell by tubes. So what is the cell by tubes? Cell by tubes are the normal tubes, but without any seam. Well, they are the tubes without any joints. One edge of the tube is very sharp so that you can drive it to the ground, and on the other edge there is some provision is there so that you can attach it drill load. What you will do? You attach with the drill load, take up to the depth from where you want to collect the sample, and drive with the help of the machine, drive into the ground and take out the sample. So this is the cell by tubes. So this is I have to tell you about the cell by tubes. Okay, normally in the projects we ask people, the project people, okay, please provide the cell by tube 38 dia. Okay. So before that I want to discuss one more thing. What is the area ratio of a sampler? Any idea about that? Because what I want to tell you, if you don't know area ratio, then you are unable to grasp that thing. What is the area ratio?
The area inner diameter of the diameter.
Yeah. Area ratio is outer diameter square minus inner diameter square. This is called the area ratio. Now, if you are collecting a sample, undisturbed sample, so depending upon that area, you can say this is the thin sample, this is the thick sample. If your area ratio is less than 10%, then it is a thin sample. And if area ratio is more than 10%, less than 25, it is thick. And beyond 25, the sampler is not good to collect the samples. Okay, because area ratio means thin sample, less disturbance, more area, more disturbance. So now you are collecting the sample. Suppose you are collecting in a you can sample in thick sample. What will happen? The sample is disturbed when the way you have sent for the testing in the laboratory. When taking out, there is some more disturbance is there. So whatever the can say result you are getting, that are not the truly representative of your data. It could be high, it could be low. So while collecting sample, only this is the very small thing. Your sample should have the proper dimensions, proper thickness. So I will tell you how it changes. So this is the table, you can see it here. If I because normally for the traction cell we require a sample of the 38 diameter. Okay, for a 38 samples, and if you are taking the thin sampler, then the wall thickness should not be more than 1 mm. But in the field, we have never found a sample which has the thickness of the 1 mm. No matter how many times we describe them, we tell them कि भाई you take a sample जिसकी wall thickness steel का tube होनी चाहिए, wall thickness 1 mm से कम हो. We always found that 2 mm. सर हमने बहुत ढूंढा नहीं मिला. सर हम लोगों ने पूरा एरिया ढूंढ लिया है, ठीक है. इवन व्हाट हैपन इन सर्टेन केसेस, इवन मंथ्स हैज पास्ट, मतलब प्रोजेक्ट में हम लोग सैंपल कलेक्शन के लिए नहीं जा पा रहे हैं क्योंकि एक सैंपलर लोग अरेंज नहीं कर पा रहे हैं. बोले सर इससे ले लीजिए, क्या फर्क पड़ता है. So you should know the intricacy. What are the intricacies? Because when you are taking a sample of the 2 mm wall thickness, its area is coming 22%. It is a thick sampler and it is a very disturbed sample. Okay, what will happen? It will suppose your results are it is a disturbed sample, and what if your results will come and your the cost of your, you can say, while the designer are designing with those parameter, the cost will be very high. So in case of the water resource project, sample collection is the most important thing. If your sample is contaminated, your result will be contaminated, your result and your design will be either highly, you can say, under design or over design, and it will affect the cost many times.
Sir, cell by tube thickness कितने का मतलब undisturbed sample?
This is you get the table, you can see it here. You are taking the 38 mm layer. This is the layer. And for the thick sampler, the area range should be less than 10. What is thickness is coming? 1 mm. So for a 38 mm sampler, the wall thickness of the tube should not be more than 1 mm. So these are the picture how you collecting samples. In the top left picture, the auger is there. In the second picture, the sample are collected, you can say cell by tubes. So these are the rock samples, and this is the SPT sampler. SPT is, you can say, split spoon sampler. Now, in case of the caustic soil, we can collect the sample with the help of a either core cutter or the cell by tubes. But when the soil is cautionless, can we collect the samples? Then what will we do? We want to determine the density of that material. Then what will we do? Hmm? Anybody collected the sample from the sand? No. Okay. In normal case, your core cutter and shell band tube will not work here. Okay. In such a cases, there are the special kind of the samplers are there. Either open drive samplers, stationary piston samplers, or rotary samplers. We use this kind of samplers, but the collection of the sample from these samplers also is a art, and it is very difficult to find any agency who is able to collect the sample even after using these samplers. But for your information, I'll tell you this is a picture of the, you can say, piston samplers. What we do it here. Yeah, this is the piston is there. So what we do here, we push the rod is here. You take out of here. After that, we insert this tube to the ground, and this piston touch the top of the your sample. Where the tube is completely filled, we lock the tube this over the sample and take out the sample. So there is a vacuum is developed between the piston and your sample, and it do not fall. But the collection, again I'm telling you, because in many projects what we feel, even after you can say searching, we don't find any agency who is able to collect the sample from the sands. So this is one of the method if your starter contains a gravels, okay, when you cannot drive and the depth of the investigation is shallow. So in that case, what we do, we make a hole into the ground, and with the help of a measuring cylinder, we determine how much the volume of that. You can say we make a, you can say, cylindrical hole into the ground. We take all the material, we determine what is the weight of that material, and to determine the, you can say, volume of that, you can say, hole, we filled the hole with the help of a measuring cylinder that contains the sands. In that way, we determine the density. Third is the ring and water placement method. This happens when your starter contains a big size of the particles like cobble, boulders. So under these cases, we use sand and ring and water replacement method. So in this method, and its name says it is this contains a ring. Ring is there. The diameter of the ring will depend on will again depend upon the size of the maximum particles. Okay. Normally, according to AS codes, the diameter of the ring should be 4 times the maximum size of the particles. So if your strata contains the boulder that has a 300 mm size, so diameter of the ring should be 1.28 meter. Okay. If bigger size particles, then the more diameter. And the height of this ring is 25 centimeter. So what we do? You make a plane surface. Just now we put the ring, and over that put the polythene is there, and over that a bench is kept. The bench contains the pointer. Pointer is there. You fix the pointer, and you mark the location of the bench on the ground. After that, you fill this let's say ring. The help of the water, and the water you are putting inside it, that is measured with the help of a, let's say, measuring jar or anything. So when this water touches the you can say tip of this pointer, you measure how much water has gone up to that level. After that, what do you do? You lift the bench. Since your location is marked, you remove all the water and remove this polythene and dig out a pit inside this ring. So whatever the material is coming, you weight all that material and determine the moisture content. Since you know the weight of that, by the knowing the weight and yeah, in this picture you can see the pit is made there. So again, whatever the material you have made that, again spread the polythene inside that ring and put the wedge in its initial position. The location you have already marked, and again fill it and measure the water, how much water is going. So the difference between the initial water and the final water will give the volume of this pit, and you know the weight of that you can say material. In that way, you can determine the what is the density of that material. नहीं समझ में आया?
पॉलिटिक्स वो मटेरियल के ऊपर है या पॉलिटिक्स के ऊपर मटेरियल
नहीं. Once you have okay, come to the my previous picture. First, make a level ground. Okay. Put the ring there and spread a polythene over there. Now put this bench and mark this location on the ground. अब the pointer है नीचे की तरफ कर लीजिएगा, but it should not touch the ground and fix it in its position. After that, with a graduated jar and the help of a measuring jar, put the water inside it and measure how much water is coming so that it can touch the tip of this pointer. So you know how much water has gone. Now take out this, take out the polythene and make a hole, make a pit at the bottom of the whatever the material is coming by digging, weight that whole material. After that, again spread the polythene, put the mat in its position, again fill it, again fill with the help of the intensive water, and when it touches the tip of the pointer, determine how much water has gone. Initially, there was no pit. In second case, there was a pit. So the difference of the both the reading will be the volume of the pit. Yeah, this is the picture of the Dibang. This was the picture of the, you can say, Dibang project. So sometimes you have see that you have to cross the river in that way. Second is the in situ permeability. This is the permeability we determine by at the field, because in the laboratory we are determining the you can say permeability of a coarse soil, but in the field if it contains the gravels and the boulders, so it is determined in the field, and this is the actual permeability of that strata. So how you determine either the pumping in test or the pumping out test? So normally we are using here pumping in test. So there are the two methods in case of the pumping in test. One is the open end method. In case of the open end method, when you have drilled a borehole into the ground, so you put a casing inside it, wash out the borehole, and conduct the permeability test. To conduct the permeability test, what we do? We power the water from in the casing, and when it is going at a constant rate, a stationary rate, after that we measure in a certain time interval how much water is going into the casing. And you know okay, this is my water use, the quantity of water that has gone, and depending upon the dia of the casing, we can determine the permeability of that starter. So this is the picture. This is conducted how we conduct the test in the fields. You are filling the water inside the casing. Second, in case of the you can say when the permeability is low, in case of this rocky strata, any strata that have a very low permeability, we carry out the Packer test, or it is this is also called as the pressure test also. In this case, what we do, we make the borehole is there, and from the borehole we provide a Packer is there. So this test was conducted at the bottom of the borehole, and at certain height we provide the Packer, and we supply the water at a pressure inside the borehole, and we will measure how much water is going inside this borehole in a certain time period. The water that is going inside it is measured with the help of a water meter, and the pressure with the help of a pressure gauge. So once you know the pressure, and the quantity of water going in the borehole, you can determine the permeability. This is a double packet test. When you want to test a specified section of that, you can say borehole. So you can say those two packets are used, one at the top and the bottom, and you are testing this section. So again here, this is a perforated pipe. Water is supplied through it, and under pressure, and water is going inside the rocks. With the help of the water meter, you can determine the volume, how much water is going. You know the pressure, and by this formula, you can calculate the permeability.
Water percolation is zero.
Hmm?
Water percolation is less nil.
हाँ तो नील नील हो सकता है. If you are conducting a test in a rock and there is no you can say fracture cavity like that, then what is your you can say probability? Probability is zero. Only in case of the rocks, there are fractures are there. So what is happening? The water will seep into the you can say.
Our aim is to know the
Yeah. It is an indicator because what is happening when you are getting the rock cores. Okay, in the rock core, it is not clear from you whether it had some certain cracks or not. By conducting this test, you know that my rock is cracked. These are the equipment that are required for the packet test. Water meter, pressure gauge, pump, and so on. I am not going to detail to that one. Depending upon the permeability, you can classify whether what kind of the strata is there. If the permeability is less than -7, it is practically impermeable. -7 to -4, -5 very poor, low, medium, high. I think I am running too late. Next is standard penetration test. What is the SPT? Any idea? Anybody has conducted this test? नहीं. Okay.
एक बार सर कॉलेज में किया था. कॉलेज के टाइम किया था.
अच्छा.
150 से 50 mm में करते हैं.
अच्छा. Good. Okay. This test is conducted in the borehole when your strata is sandy or clay strata. Okay. But if there is gravel, we cannot conduct this test. So to conduct this test, the minimum dia of the borehole should be 100 mm. So in this test, we use a split spool sampler that is attached with the drill rod, and it is lowered inside the borehole, and we provide the blows with the help of a hammer that has the weight of 63.5 kg, and it falls from the 75 centimeter. So we drive it 15 centimeter. We know how much number of blows are required. The first 15 centimeter is called as the sitting drive. We again drive for the 15 centimeter and calculate how much number of blows are required. Again drive it. So in last 30 centimeter drive, number of blows is called as the SPT values. Here I can show you that one. So this is a typical picture of split spoon sampler. Why we call it split spoon sampler? Because this is my sampler. This is my cutting shoe. So if I remove this cutting shoe, I can open it into halves. That's why it is called a split spoon sampler. So when you are drying into the ground, whatever the material is there, it is coming inside. So we get the idea what kind of the either, although it is a you can say disturb sample, but we get the idea of what kind of the material is there. So these are the dimension. Normally the cutting shoe dia is 38 mm. But if we are using along with the diameter, the diameter of this cutting shoe will be 35. So how you conduct it? So this is the picture. You know the first of all, you make the borehole. You clean the borehole, so there is no loose material at the bottom of the borehole. You drive the sample, leave it for certain times, and let it allow it to settle by its own weight. Okay, certain times it was observed in case of the highly you can say fatigue clays, a sampler by its own weight it is sinking into the ground. Then SPT value is 0. Okay, once it is driven, apply the can say blows with the help of a hammer that has a weight of 63.5 kg and which fall from a height of the 75 centimeter. It is called as the sitting drive. Now again drive it 15 centimeter, count the number of the blows. Again drive 15 centimeter, count the number of the blows. Last 30 centimeter number of will give the SPT values. So this is the picture of the how we conduct the SPT test. In one I have written right, other is I have written wrong. Why? Can you make the difference? What is the difference in both the pictures? Yeah, okay. On the left side, you can see when I'm drawing the, you can say, when hammering the, you can say, my anvil, my guide along is almost same, almost straight. But in the second picture, you can see it here. Guide is tilted. So when you provide the force in that way and when you provide the force in that way, there is some difference there. So it will not supply your complete energy. So what will happen? Your SPT value will be high because it might be that you are supplying only 60% or 70% energy. So your SPT value will be high. So once you know after conducting the SPT test, depending upon this data, you applied certain corrections. First is the overburden correction. In case of the Sandys data, we apply the overburden correction. So this is the graph with which is shown. With the help of this graph, we determine the value of the CN and we correct for the overburden corrections. Second is the in case of the fine sand, yeah, silty soil, and if n value is greater than 15, we apply the dilatancy correction. So after the correction, once you applied the corrections, you determine the what is the angle of the friction is there. According to the pack, your n value is varying from 5 to 50 and the angle of friction is vary from 28.5 to 43. Once you know in case of the sandy soil, you know C is 0, you can determine the shear strength. Meyerhof given this is the correction that is given by this is you can say correlation that is given by the Meyerhof. According to him, if n value is less than 4, then it is a very loose strata. 5 to 10 loose, 11 to 10 30 medium, 31 to 50 dense, and more than 50 very dense. And these are the relative density 0 to 15 depending upon your strata, 85 to 100. So on the basis of the n values, we can say whether it is a compacted strata, loose strata, what kind of strata is there. So this is regarding about the sandy strata. When we talk about the coastal strata, a clay soil where we conducted the you can say SPT test, may have given the another correlation. This is the area. Depending upon your SPT values or n values, you can say whether your strata is soft, medium, stiff, very stiff, or the hard. So, what are the drawbacks of the SPT? Energy transfer. First thing is the energy transfer. In case of the SPT test, energy transfer is only 50 to 70%. So, whatever the SPT values you are getting, that are the high values. Okay. Improper height of the drop. Your hammer should be dropped from a height of the 75 centimeter. But if you can say what your technician who is doing the manual hammering, if the height of a drop is more than 75 or less than 75, accordingly the number of the blows will be high or low. Top condition, IS code prescribe a special kind of rope that is called the Manila rope. But in most of the cases we have seen when doing the SPT, they are using the wire. Okay, wire have its stiffness. Again, the number of the you can say blows will be high. So these are the normal drawback the SPT and these are the common mistakes. आपने borehole clean नहीं किया proper. First thing is the cleaning of the borehole clean नहीं किया तो what will happen? There is some sand is there some you can say material is there inside your casing. So it means you are conducting a test in a confining environment. The SPT value will be high. Second thing is the your SP sample not resting on the disturbed sample. While drilling, you have disturbed your bottom strata. SPT value will be high, low. failure of the wood bed, in case of the sandy strata, water table is there. So when you are conducting the SPT test, the level of the water in the casing should be 1.5 meter from your water table. Otherwise, what will happen when you will clean the borehole? The water will start boiling from the end, and it will make your bottom strata loose. It will you again give the, you can say, low value. So these are the mistakes you conducted that happen in case of the SPT test. This is you can say long list of that one. Since I am running short of the time, so these are the bore logs. Normally, let me tell you about only one thing about the borehole. Either you have to go to the full report, but only by looking at the borehole you can say what are the result of your foundation strata. Here everything is written. What is my SPT values? Then what is my permeability values? Here I have collected the, you can say, UD samples. What kind of the strata is there? Only by looking the, you can say, borehole you can tell what are the characteristics of my strata. So borehole should be made in that way. It will provide all the information regarding the strata. Second is the dynamic cone penetration.
Because, so can you explain a little bit about the order of the SPT corrections?
Yeah. Suppose in case of the sandy strata, because this correction is applied only in case of the sandy strata, not for the strata. So what will happen? Suppose your depth of the casting is 10 meter. Okay, you know the density of the strata. So how much pressure will give? This is triangle pressure is at the bottom. WH 1 minus sin phi 1 plus sin phi. This pressure density will come at the bottom. You know this pressure is coming. Determine that pressure, and from that pressure, so there is correction factor is there. Pressure is here, and there is correction factor is here. So up to 1 meter, there is no correction. But beyond that,
After 1 meter, correction is required.
After 1 meter, correction is required. Up to 1 meter, you don't require any corrections.
Sir, as per IS 1893, some notifications. As per 1893 IS.
2171 is called 2171 is the export for the SPT. Okay.
Yes,
we have to conduct according to that one. So this is the picture from the 2171. Okay. Whatever they say, we have to follow that one. Okay. So tell me your query.
My question is that, sir, so 2131, sir, one of the IS codes, another is the 1890. Seismic plus, sir, IS code.
Seismic properties have the different properties. Do not forget about seismic property.
So the my question is that, sir, suppose in case of the art amendments, so this correction is required. So this type of correction is considered, and that correction is required.
Right. This correction is required for the SPT values. When you are coming to the correct SPT values, suppose you have conducted a test at a depth of the 10 meter, 15 meter. Okay, due to the overburden pressure, the SPT value come around 50-60. But the actual value after applying the, you can say, overburden pressure, the value will come around to 25 to 20. That is it. That's why it is required.
ये भी सब जब अवेलेबल होता है जब ओवरबर्डन प्रेशर 20 किलोमीटर पर एक्सप्रेस से ज़्यादा कम हो ये ओवरबर्डन प्रेशर भी जब तभी अप्लाई करता है जब ओवरबर्डन प्रेशर हमारा 20 किलोमीटर
again, right, if you take the density, what the density of the sand 1.8, 1.9, up to 1 meter, how much pressure? To around 2000 kg. That's why you apply up that one. Okay, should I proceed further? Dynamic cone penetration test. So this is a very simple test. Okay, this test do not require any kind of the borehole. It is a very test and a very quite rapid test. Normally at the feasibility stage of the project, we conduct this kind of a test. What we do here? So this is a normal thing. There is a cone is there, and this apex angle is 60 degree. Okay, and dia is around 50 centimeter. So what we do? We attach this cone with the drill rod, and we provide the blows with the help of a 65 kg hammer that fall from a 75 centimeter height. So for each 100 mm drive, we count the number of the blows is there. So this test and the total number of the blows that is required for the 300 millimeter penetration, that is called as the dynamic values of that one. This test gives us the continuous. This test gives us the continuous profile of the ground. You can see here up to 30 meter, 30 centimeter, 60, 90. So in that way, you can get the continuous profile of the strata. But the only thing that we do not get any kind of the sample, either disturbed sample or the undisturbed sample. So this is only based upon that you can say these blows. We can not conclude that, but we can after knowing conducting this test, we can plan our detailed investigation. We can plan okay, where should my borehole. Suppose one place your expected your values are quite low, at other place is quite high. You can say okay, my one borehole should be there, one is there. So in that way you can plan your detailed investigation. Next one is the static on penetration test. This is a very good test, and this is applicable for the sandy and the cossy soil. This is applicable for both kind of the test is there. The benefit of this test is that it gives us the bone penetration as well as the skin friction. So in this test, there is a machine is there, the plunger is there. Yeah, this is the plunger is there. We drive this plunger to the ground, this core to the ground. It gives us the penetration, and along with that, this is our friction jacket. When we again move this one, then our cone and the plunger both are moved in that way. So we get the total pressure that is required to drive friction jacket and the cone. So normally the dia of the cone is 60 degree and its dia is 35 and dia of the friction jacket is 36. Slightly more than you can set your cone. So first we do first bend the cone 4 centimeter to the ground. Again move it and drive over the cone and the friction jacket. Determine the resistance. So these are the length of these are some dimensions of these instruments. So this machine is the two kind of there are the two types of machines are there. One is the hand operated, that is has the capacity of 2 to 3 ton. Other is the you can say machine operated that has a capacity of around 10 ton to 20 ton. So how you do it? So this is the cone. This is the picture is here. First you drive, you define the quantity cone resistance. Second after you drive cone plus friction jacket, we get both the resistance. So by knowing the cone resistance and the friction resistance, you can determine the shear strength of that of soil. So nowadays electric cones are there. The help of that one, you can also determine the pore pressures also. Electric cone, you can say electric cone. We call it electric cone because initially what is happening? We determine the cone resistance with the help of the pressure gauge. But nowadays electronic transducers are available. These are attached inside that one. And with the help of that, we can measure how much is the cone pressure, cone resistance is there, what is the friction resistance is there. Knowing the cone friction and the release friction, we can determine the friction ratio. And depending upon that, so this is the picture of the results. We draw the curve, this is the cone resistance, this is my friction resistance, and this is the pole pressure. So depending upon the cone resistance and the friction resistance, we can get the idea of what kind of strata is there. Because in this case also we are not getting any kind of a sample. But here you can see here, clay is here. It has the low cone resistance. It has a high skin friction. Here clay silting again here, but when you go to sandy soil, you can see it here. Sandy soils are there. Core resistance is high, friction resistance is low, core pressure is low. So this is the chart. Based upon the chart, once we know the core friction and the friction ratio, we can say what kind of strata is there. If it has the say, high core resistance but low friction ratio, it means it has the sandy strata. But if it has the high friction ratio and the low core resistance, it is a clay strata. Plate load test. Plate load test is the test that gives us the bearing capacity, settlement properties, deformation modulus. Okay. How we conduct? We conduct it according to the IS code 1888. So normally for this test we use a plates, steel plates that has the thickness and the dimension vary from anybody. The dimension of the plates vary 45 to 30 by 30 centimeter to 30 centimeter, 40 centimeter square plates, 75, 50. These are the size of the plates. How we choose it? Suppose you. Type of soil there. Good. You will decide it how the type of soil is there. But so for the clay soil, which kind of plate do you want to use? Okay, let me tell you. So these are the different sizes of plates that vary 30 centimeter by 30 centimeter. The size of the plate should be at least 4 times of the maximum particle size. 5 times? 4 times, 4 times. So not less than 4 times. Okay, it could be. Check it with the codes. Okay. So if your particle size is 30 centimeter, you can say like that. So depending upon the particle size, we choose the plate of size. In case of the Cauchy soil, we normally use where the particle size is low, 30 by 30 or 40 by 40. But for the sandy strata, that's strata that have the grade, we use either 60 by 60 or 70 by 75 centimeter plates. How you conduct this test? So this is the typical picture how you conduct this test. This is the bearing plate is there. Let me right from the beginning. Okay. So first of all, make a bit that has the size 5 times the dimension of the plates. The dimension of this plate should be 5 times the size of the plates. So if we are using 60 centimeter size of the plate, then the size of the pit shall be 3 meter by 3 meter. Okay. You put the plate here. Okay. After the putting the plate over here, you measure the deflection of this plate with the help of the dial gauge or the help of the LVDT. And you put the steel columns there. Over that there is a girder is there, main girder is there, over which load is applied either by the gravity loading, in which you put the sandbags or the concrete blocks, or by the reaction loading. Either fix this girder with the help of the anchor, and there is a jack is there. When you apply the pressure in the jack, what will happen? It will try to lift here. Since there is a gravity loading or the reaction loading, the pressure will come on the plate. So this is the things 5 times the size of plates. So this is a typical picture. Yeah. Plate is here. This is steel column. You have to put the jack there, and this is the girder. Between the girder and the jack, steel ball, steel socket is there, which shows that whatever the load is coming, that is coming vertically over this one. And these are the dial gauges. With the help of that, you measuring the deflection. So what do we do? Put the plate on the ground, and first of all apply a sitting load, that is 0.7 ton per meter square. After that, whatever your bearing capacity you are expecting from a strata, so the load is applied on 4 to 5 increments. Suppose your strata has a bearing capacity around 20 ton, then you apply the first increment 5 ton. After application of the load, what we do, you measure the deflection of the plates with respect to time. Okay. And after certain time, when the deflection of the plates ceases, yeah, it becomes less than 0.20 meter per millimeter. Stop that. After the apply again next increment of the load, it means initially if you applied the 4 ton, applied 8 ton, again measure the deflection of the loads. In that way conduct this test. The test is conducted until unless the deflection of the plate is 25 mm. Yeah, it is double the design load. So this is the, you can say, gravity loading, picture of the gravity loading. So this is the thing, the plates are there and the dial gauges are there, signal measure. This is bar and solenoid, this is the jet. The pressure is measured with the dial gauge. This is the actual picture of the PLT test. Now you know the what is the load. Suppose initially you have applied the 4 ton load after 8 ton load. So there is final settlement. Plot the curve. Depending from the curve, you can determine the bearing capacity. In case of the, let's say, stiff gravel soil, a stiff place, the failure is clear. It is failing here, it is failing like from here. But when the sandy soil is loose, a clay soil is not clear. Here, failure is not clear. Where is failing? Can anyone tell me? No, sir. Failure is not clear here. So in that case, what we do? We plot the load settlement curve on log scale. So that gives the clear indication to where the soil is failing. From there, you can determine the ultimate bearing capacity, and applying the, you can say, correction, factor of safety, you can determine the total. From the plate load state, whatever the settlement of the plate, you can determine the actual settlement of the footing also. From this formula here, B is the dimension of the actual footing, and this is the B is the dimension of the plate. From this formula, you can calculate what is the settlement of my footing. Vein shear test. What is the vein shear test? This is used for in case of the clay soils. It is not applicable to sandy or silty soils. In case of the vein, let me rapidly cover it. In case of the vein shear, this the vein is this kind of the veins are used. Okay, these are the mutually perpendicular plates. So what we do here, make a borehole and just drag this vein into the ground, and with the help of the torque applicator, you rotate this vein, and whatever the torque is required, on the basis of that you calculate what is the strength of the clay soil. It gives you the undrained shear strength of the soil. This is the, you can say, machine with the machine. What is happening? These are the road extension road is there. This extension road is attached with here, and at the bottom of the borehole, your vein is to the borehole, and you rotate with the help of the handle at the rate of 2.1 degree per second. So this is the picture. You can see it here. This is my borehole. I should. This is my depth. After that, I will insert into the ground. This line should be minimum 5 degree. 5 times diameter of the borehole. After that, I will rotate it and determine what is the maximum torque is there. With the help of this formula, I can calculate what the shear strength. There is one more benefit of this instrument is there. I can calculate the sensitivity of the soil. How will calculate? Once I determine the maximum torque, I will rotate it very fast and make the 10 to 20 revolution and leave it for the 15 to 20 minutes. Again rotate it, and what is the torque is coming? The initial torque and the maximum torque. That ratio gives the sensitivity of that soil. So this is the last one, pressure meter. Okay. So the pressure meter, what is the pressure meter? It is used for measuring the in situ deformation and the modulus of soils. It is very good for the clays, soft weather rocks, and so on. So this instrument mainly contains the two things. One is the probe, and other is the monitoring unit or the volumeter. So this is the typical picture of the pressure meter. In the middle, you can say this is my measuring unit. This is my measuring unit. The pressure gauge are there. With the help of that pressure gauge, I can measure the what is going to be my water pressure or what is my air pressure. This is my probe that is inserted into the borehole, and with the help of the water and the air, inflate it into the borehole and determine how much pressure is required to inflate it. Because when it inflates, it touches the borehole walls and it squeezes and it compresses the borehole walls. Just so this is the typical picture. Basically, this probe has the two kinds of thing. Probe has the two kinds of cells are there. One is the measuring cell, other is the guard cells. This is my measuring unit. Both are connected with the help of the line. That is the gas line and the water line. So this is the typical picture. This is one of the my props, and this is the props that in case of the weather drop, when there is rocks are there. It has the rubber casing, so it may damage to that case. We are using the steel casing props. Here you can see this is my prop. The center prop is the you can say measuring cell. It is inflated with the water, and the side props these are called as the gas. These are inflated by the gas, and the pressure in the central prop is slightly more than the my guard cells. Why? Because what will happen when this prop will inflate it, so both ends become cylindrical. To keep them vertical, so that they can touch the borehole wall vertically. So we inflate the guard cells. So these are the sizes of the you can say pressure standard probe hole boreholes, either 44 to 74, but only limitation in this method you require a good driller which can be provide a good borehole. If the size of the borehole is more than whatever the you can say probe you are using, you will not be able to conduct this test. Because in case of the XI probe which has the diameter of 74, the borehole diameter should be 76 to 80. So many times we have seen that in the projects, the people say, "Sir, our borehole is ready. You please come and conduct the test." After reaching that, we found that the diameter borehole more than 80 mm. And you are unable to conduct this test because that probe has the limitation to expand. Beyond that, we cannot expand it. Okay. So if you are conducting the test at 40 meter and you have taken 10 days or 15 days to make that borehole, all your exercise that has will be gone. So only thing is that your borehole should be accurate dimension. So this is my curve. How you conduct it? So this is my pressure meter. I will attach it with a drill hole and take out my test location. My test location should be always uncased. There should be no casing. My casing is ending here, and this is my wall of the boreholes. Okay, I have taken this one. After that, I am expanding this. When it expand, we compress the soil around it, and we determine how much pressure is required. So once you have determined the pressure and you determine how much the volume of the water that has gone to inflate your basin crop, this is the you calculate the results. Okay, this is the thing here when you started inflating it. So this is the thing up to here. There is no increase in pressure. Why? Because here we touch the wall of the boreholes. After that, there is elastic deformation, and beyond that, there is a plastic deformation. And this after that it becomes vertical, and this is your limiting pressure. So by the you can say the slope of this curve plastic model it will give the plastic modulus. So how you conduct it? First of all, take inside the borehole, apply the pressure, and measure how much water is going. That is measured according because this is an automatic apparatus that is automatically recorded inside it. Again, apply the pressure and measure how much the volume is changing. So this is the value of the limiting pressure for different kinds of soils. And shipping this one. So this is the project we have conducted the Lakwar Dam project. Okay. This pressure meter test was conducted at the Lakwar Dam project. So let me tell you about this one. The dam is around this is 200-meter height. So what is happening to them? The investigation was done quite a long back. I think the investigation was started in 1970. But there is a shear zone that has a width of the 10 to 15 meter, and it's passing through the toy of the dam. Yeah, this is my dam structure. This is my shear zone. Okay. To do this shear zone, there are the, you can say, high deformations are there. So after initial study 1970, the site was abandoned because the deformation was so high. So the dam construction was not possible. But what happened nowadays? We have exhausted all the good sites. So whatever the sites is remaining, we have to utilize to increase our, you can say, hydropower potentials. So for that one, again the project has started. But the thing is that the designer is asking, I want to know what are the properties of this year. So we try to collect the sample. The material was so hard, we are unable to collect the sample. We are unable to conduct the SPT test. No other test was possible there. So how we characterize this shear zone? So project authority approached us and we decided to conduct the pressure meter test there. So initially, depending upon the, you can say, geological study, it was observed that on the right bank, shear zone is 90 meter, but on the left bank of the, you can say, river, the shear zone is encountered at a depth of the 5 to 10 meter. So we decided to make the borehole there since the height is very low, depth is very low. We can conduct it very easily there. So they started drilling the borehole, but even after you can say drilling 15 meter, they not encounter shear zone. So this is the, you can say irony of the non-invasive techniques. When you make the prediction based upon certain indirect studies, that this is the location, so it happens always. So anyhow, then shear zone was encountered at a depth of 20 to something meter. So we asked to make the three number of the boreholes, but what happened? We are These are the location of the boreholes. So, but we are able to conduct the test only in two boreholes. What happened in third borehole? They have driven up to 40 meter, but the driller was not good enough, and he made the borehole very large. So we have to, can say, abandon that hole because we are unable to conduct the test. We conducted the test and we determine the properties. So these are the picture when we are conducting the test borehole. So this is the preparation. This is the prop is there. It is attached with the drill hole, and these are the lines through which water line and gas line are passing. So this is the line is connected with this pressure meter, where we can measure the pressure. So, so these are the results of that test that are conducting the boreholes. So depending upon that, you can say test, we have characterized that shear zone has the, you can say, stand 44.75 kPa. The limiting pressure on this one. So at least we can provide some data to the designer, so he can design the project is there. So this was the one of the things, and I don't think so. That much time is there, sir. I should skip it. I think so. I think yes, you have to. Yeah, this is the study about a bore area investigation. This is really a amazing story because yesterday in the morning, in the early, I told you that you have to collect the sample very properly. Here, what's happened here? The two dams are proposed to be constructed in that Rajasthan. One dam was 7 meter high, other was the 19-meter high. Initially, it was proposed because it is Rajasthan, the rocks are easily available, so we have to design the John dam. Okay, so only thing that is required, what is required? The clay, so that we can make the core is there. Okay, so what happened? The project authority identified certain area. We collected the samples. They have identified the four bore area, and based upon the laboratory investigation, we tell sir one area is good. We can use this material. Okay, so that exercise took 3 months. I think that was the beginning in the January. So up to March we have given the reports, and we said that your area is okay. You can start your work there. When the project authority went to take the sample from there, it was resisted by the local people. They said we cannot take the, you can say, soil from here, you have to pay for that one. And it is a big quantity, and they are asking too much money. So at least it was abandoned. So since it was April and in Rajasthan, monsoon comes in June and July, down in June. So in hurriedly, what the project authority has done, they have identified some new bore area, and they have collected the samples and they sent to CSMRS. So we studied the sample, and on the basis of investigation, we found that this is a GC kind of a material. So I told you in the beginning, that GC is a very good material. Earlier we designed the, you can say, John Dam, but since it is GC material, we said okay, the CWC has said okay, go for the homogeneous dam. How the design is changing, depending upon your material, your design is changing. So now the GC material is available. That's a good thing. But since our team has went earlier, so we are very surprised how the GC material is available in that area. So we instead, okay, at least let us recheck it. Okay, what kind of material is. So we sent a team there and they collected the samples. And after our team has come and we tested in the laboratory, we found it is a SM kind of the material. Now the things are again changed. You don't have the material because SM kind material cannot be used for the construction material. Now the onus is again after that monsoon has started, so we cannot in the monsoon season we cannot do any kind of investigation. So in that way, all things, well, 7 to 8 months have wasted. Later on, there was a pressure on the project's peoples. They have identified some more area. At this time, what they have done in Rajasthan, there is a water bodies are there. That water is used for the drinking and for the cattle purpose. So they say such clay is there. You collect and you take the sample from there. So in that way, they identified the phone number of the bore areas and sent the CSMRS team went there and collected the samples. And out of the four bore area, two bore area, sample was CL and CA type. That was the good one. So we said, okay, you go ahead and construct it. Again, the same thing was happened. They are unable to collect the samples. Well, they are unable to take the sample from that earth from that areas also because the people whose panchayat was there, the land was there. So due to some political and other things, they are unable to take the sample. It means complete 1 year was lost in that way. After that, what they have done, they purchased the land, some of the, you can say, landowner, and they borrow that land, and we again done that same exercise, and they identified this time three area. Out of three area, one area was good, and yeah, this is the picture. One area was good, and this one, and the sample was good, and they collected the sample. We collected the sample, and it was found good, and the 10% was started there. So many times what I want to tell you is that while collecting the sample, you should take the every care. Whatever the material you are collecting, something for the investigation or testing, you will get the same results. So you have to take the samples very properly. I told you how to take the sample. Do not make any mistake, otherwise what you will jeopardize all the, you can say, your projects. Now any question? I know it is quite long, but I try to cover it because field investigation is a very long field. It is very big. If I take them in every test, well, a single test, it will take hours to explain to you. So I just wanted to give an idea. Okay, at least you should know the name. Okay, this is my special. This is what for this one. This is PRT. This is the limitation, and these are the things. You should know only because you are not going to conduct that. But at least you can suggest when you are dealing with the project, you can say, sir, SPT यहाँ नहीं हो सकता. Okay, because starter contains the gravels and the bolts. Other tests can possibly be. So you should have that much of. Any question? I think there is no more question. So let's break for the tea. Thank you. अभी अभी चाहिए मतलब एक इंजीनियर सर आ रहा है one of the test which Mr. Shahid has introduced is the pressure limit test and pressure limit test is one of the advanced tests which many organizations are not having.
It's only at CSMRS that we have procured this facility. And really a very helpful test. I'm using it for many years now. You should know about this test also. Remaining things are known. See, you hear about SPT, you hear about DCPT, ECPT. But determining test for the soils, it's a rare type of.
It is a rare type. Or second thing, when you fail, okay, no, I don't have any option. I cannot do any other test, but I want the properties of my setup. So in that case, it works. And thankfully, we have this facility. What of the sir is telling you, there are only cancer 1 and 2 ordinance in India which have this kind of facility. Just we have finished. Yeah, my lecture is covered. Yeah, I'm just asking. If you have any question, you can ask me regarding anything about that. The only thing is that because you are on the field pills and you are responsible for the collection of the sample and sending to the laboratory. So you have to take the utmost care about that one because a small negligence will change all the design parameters, the costing of your project, it can change it. Even while collecting the distance sample or the UV sample like that, here I told you explain, depending upon the material, it can change your design. Depending upon you can say your whatever the sample collection, disturbance to the sample, it may increase the cost of your project manifold. It may over design, it may be under design. We have to take care about that. I know after my lecture you don't be expert with everything, but you should know that these are the things when because you are the field people. You have to collect working the field, collect the sample. Rest of the work goes to the laboratory and the designers. But you have to play your part very good. You should know what they can say. Here I have to take that. So in my lecture, if you want to ask anything, I think. There is heavy dose is there, I think so. So there is no more question, I think so. Hmm? Okay. So how many people have heard about the SPT? You. ECPT? नहीं सुना. ECPT. Good. But at least you should know that. I have done the packer test. For the packer test. The packer test for the you can say permeability. Permeability. Where you have done it? In Sumajiri and Tulsi. Okay. Because I think in Northeast, the person who are involved with the, you can say, erosion work, there is no chance for that one. But here you collect the sample, no? Because in case of the, you can say, bank protection, what you collect the sample, you define the properties, so like that. So I think so. I think we closed. Okay. We closed for the. I think we should thank Shahid for. Thank you. If later if you have any query, you can mail me or you have my WhatsApp number. You can ask me anytime. Okay. You are most welcome. Streaming to 130. बंद कर